just hold this.
Okay. Oh, it's weird being videotaped now. Okay, special right triangles, there's two triangles we're going to be focusing on. The first one right here, you can identify it by the angles, 45, 45, 90-degree angle. And that's actually what we call this, the 45, 45, 90-degree triangle. And in this, it's isosceles, so this and this are the same length, so whatever this length is also this length here. And then the hypotenuse is x times square root of 2. So to go from the side length to the hypotenuse, you can just take that value and multiply by square root of 2. So for example, if this was 3 and 3, then you can just multiply 3 by square root of 2, and the length here would be 3 square root of 2, like that. I'm going to go back to the original just so you can use it as a reference. But this is special right triangle number 1. Now, to get from this side to this one, so let's say you were given the hypotenuse length and you needed to get the side length, you would have to divide by square root of 2, and then get this side length, and we'll practice that in the lesson. Then over here, the other special right triangle is called the 30, 60, 90-degree triangle. This being the 90-degree angle, of course, and then the smaller of the two angles would be the 30, and then the larger of the two angles would be the 60-degree angle. With this, there's 3 different side lengths. This would be your short side, so you can just label that S. The hypotenuse is twice the length of that, so that would be 2S. And then this, our medium length side, is S times square root of 3. So if you had this measure right here, if you had one of the sides, you could figure out the other two. You could just multiply it by 2 to get the hypotenuse, or multiply it by square root of 3 to get this side length. Also, if you were given like this length, you would have to divide it by 2 to get the short side. Or if you were given this length, you'd have to divide it by square root of 3, which we'll see in the notes today. So that's the gist. First step in these problems is just to identify which type of triangle it is, and then use these ratios, essentially what they are, to figure out side length. So in the notes, thank you. Okay, so starting at the top of the notes, it actually starts out with a square, and you might be thinking, okay, what does a square have to do with what she just showed us? Well, it says find the length of the diagonal of the square. So diagonal from B to D right here. Okay, with that diagonal, then you have the triangle that's the 45, 45, 90-degree angle. And over here, it says, okay, what if the side length of the square is 1? So I'm using pencil because I might erase. What if the side length here of the square is 1? What would the diagonal be? Well, you could use Pythagorean theorem, 1 squared plus 1 squared equals c squared. You'd get 1 plus 1 equals c squared. And the answer would then be square root of 2. So c, the diagonal, is square root of 2. So when the side length is 1, the length of the diagonal would just be square root of 2. Whoa, it's blurry. Okay, if you were to put 2 here and do the Pythagorean theorem, then you would get 2 square root of 2. And if you put 3, it would solve to 3 square root of 2, 4 square root of 2. And if it was 25, you'd get 25 square root of 2, or any side length, n square root of 2. So the diagonal of a square follows these rules. Okay, moving on. So the notes are going to start out with the 45, 45, 90-degree angle, or triangle. It's an isosceles right triangle. It can be formed by drawing the diagonal of a square, which I just mentioned. So here's an example here. It shows the legs are the two that are adjacent to the 90-degree angle, and the legs are the same measure. And then the hypotenuse is essentially the leg times square root of 2, if you want to think of it like that. Okay, so we're going to fill in this chart. This chart might help you through the problems. So in the chart, if you were given the leg length and you want to find the hypotenuse, you would have to take the leg and multiply it by square root of 2. And if you were given the hypotenuse and you're trying to find the leg, then you would take the hypotenuse and divide it by square root of 2. And there's a little example over here as a reference. Okay, now looking at the examples with number 1, it says find the value of x and y. Okay, well, it's a 45, 45, 90 degree angle, so it's going to follow those rules. So that means the two legs are the same length. So this would be 10. And then for the hypotenuse, you would multiply by square root of 2. So 10 square root of 2. And that is y. Your answer choices on the homework and everything will be in this format. So, okay, the second one shows us the leg right here is square root of 6. This leg would be the same length, so this is also square root of 6. And then to get the hypotenuse length, we multiply by square root of 2. So it's square root of 6 times square root of 2, which would be square root of 12. However, that's not in simplest form. So we can break up 12 into square root of 4 times square root of 3. Square root of 4 is 2. And so this is the answer. So you might be thinking, oh, I'll just plug that in a calculator and I don't have to worry about simplifying like that. And that's what my first period tried to do, and it actually makes the whole process more complicated. So focus on simplifying, because a lot of times you can simplify it easier than actually trying to figure out how to plug that in a calculator. Okay, number 3 shows one of the legs here. This would be the same measure, so we got that. And then here, multiplying by square root of 2, 3 times square root of 7 times square root of 2. There's no perfect squares, there are no way to simplify, so the answer is just 3 square root of 14. Okay, moving over to number 4. Okay, so here is where we're working backwards from the hypotenuse to the leg length. So to work backwards, we actually have to divide by square root of 2. So the way this would look is 4 square root of 2 divided by square root of 2. So my first period, they were trying to plug this in a calculator, and it really doesn't work very well. But if you notice, square root of 2 divided by square root of 2 just cancels out, and the answer is just 4. So 4 represents this side length, and then because it would be the same length here. Okay, number 5. Okay, we're given the hypotenuse is 12, and we have to go to the leg length, so we're going to divide by square root of 2. So 12 over square root of 2. Okay, that's great, but we can't have the radical as a denominator. So to get rid of that, you have to multiply by square root of 2 over square root of 2. Then you get 12 square root of 2 over 2. And then to simplify this, 2 and 12 can both be divided by 2. So we get 6 square root of 2. And that represents the side length, 6 square root of 2 here. And then x would be that as well. Okay, number 6. Again, they gave us the hypotenuse. We're working backwards to find the side length. If it's hard for you to figure out what to do, remember you could always look at this chart here. You're going from hypotenuse to leg, divide by square root of 2. So this chart might help you more than the concept. I don't know. Depends depends on how your brain works, I guess. So if to go from this to this, divide by square root of 2. 4 square root of 6 divided by square root of 2. And then from here, 4 times, I'm breaking up the 6, square root of 3 times square root of 2 over square root of 2. Then this cancels, and I'm left with 4 square root of 3. So this is 4 square root of 3, and so is this. Okay. How do you feel so far? Okay. Remember, we're spending another day on this too, so. Okay, next. Now we're moving on to the other kind of triangle, the 30, 60, 90. Here it shows the 30, 60, 90. They labeled it a little bit differently than I like to label it. Honestly, I like to call this short, medium, and long. So as I go through that, that's how I'm going to refer to it. Also note, this 30, 60, 90 can be formed by drawing the altitude of an equilateral triangle. So here it shows it here, an equilateral triangle, the altitude being the height, and then you have two 30, 60, 90 degree triangles. And that's something that actually comes up in the homework. They say, okay, you have an equilateral triangle and an altitude, and then it wants you to find different dimensions. Well, that means that these would be 30, 60, 90 degree triangles right here. Okay. Looking at the 30, 60, 90, it has the ratios right here. Your short side, like I said, I like to just label this S for short. And then the hypotenuse is 2 times the short. And then the medium over here is the short side times square root of 3. Okay, so we're going to fill in a chart. So let's say you're given the short leg and you want to find the hypotenuse. So that would be from here to here. To go from here to here, you'd multiply by 2. So short times 2. Okay, what if you're given the short leg and you want to find the medium side? You'd be going from here to here, so you multiply by square root of 3. Okay, and what if you are given the hypotenuse and you want to find the short leg? So to go from here to here, so to go this way, you would divide by 2. So you'd take the hypotenuse and divide by 2. Or just have it is how I would probably think of it. And then the last one, if you go from medium to the short leg, so if you're going from here to here, you'd have to divide by square root of 3. So medium divided by square root of 3 would give you the short leg. So when you're doing these problems, if this chart helps you just to like identify what's given and what you're trying to find, you could match it up and then use that operation. Okay, all that being said, let's see, maybe I'll make a little image down here. Okay, so here we're going to start the examples. Right next to this first example, I'm going to sketch myself out that 30, 60, 90 degree triangle. This would be 30, this is 60. So this is my short. The hypotenuse is 2 times the short, and then this over here is S square root of 3. Okay, based on that, finding the different values, we're given the short side. We can multiply that by 2 to get this. So x equals 24. So this is like multiply. Okay, then to get this guy over here, we multiply by square root of 3. So y equals 12 square root of 3. Okay, number 2. Okay, they gave us the short side. Cool. Then I can just multiply that by 2 to get this side. So it'd be 12 square root of 5. And then to go from this to this, I have to multiply by square root of 3. So 6 square root of 5 times square root of 3 be 6 square root of 15. It's not pretty, but it is what it is. Wait. Yeah, okay, I'm looking at the wrong problem over here. Okay. Next, number 3. Okay, they gave us the longest side here. To go from the long to the short, we're going to divide it by 2 or halve it, so x would equal 8. And then to go from this to the medium side, we have to multiply by square root of 3, so y equals 8 square root of 3. Okay, 4. Okay, they gave us the longest side. To get to the short, we divide by 2, so x would be 4 square root of 6. So as you can see, if you understand radicals, then you don't need to plug that into a calculator. You just can say, okay, half of 8 square root of 6 is 4 square root of 6. And then from here, we multiply by square root of 3. So 4 square root of 6 times square root of 3. We can simplify this. I'm going to break up square root of 6. So 4 times square root of 3 times square root of 2 times square root of 3. And you get 4 square root of 2, and that's your length here. Okay, then 5 and 6, they give you the medium length side, and then you have to figure out everything else. So they give us the medium length side, and we have to work backwards. So to go from medium length to short, and again, we could look at this here, medium to short, we have to divide by square root of 3. So medium to short, dividing by square root of 3. So 9 square root of 2 divided by square root of 3. I can't keep the radical as a denominator, so I times it by this. 9 square root of 6 over 3. Then divide both of these by 3 to get 1 and 3. Get 3 square root of 6. Okay, so 3 square root of 6 is the short side, and then you can just double that to get the long side. So this would be 6 square root of 6. And then number 6 is the same process. We're going to divide by square root of 3, so 21 over square root of 3. I can't have that radical in the denominator, so I multiply by this. My first year teaching this, I tried teaching this before I reviewed how to simplify radicals, and that went really bad. So at this point, you do 21 times square root of 3 over 3. Divide by 3 is 1. Divide by 3 is 7. And you get 7 square root of 3. Then double that to get 14 square root of 3. And that's it. Okay, so for your homework, Oh, there is one thing I want to go over before you get in the homework. There is a specific problem that people had problems with this morning. So there is a problem where it says, okay, you have a square, and the diagonal of the square is 16, I don't remember, 16 something. Yeah, what's up? Oh.
Number 4, wouldn't it be 12 radical 2?
Did I mess something up? 4 squared is so number 4, you're saying here. Let me pause. Okay. So, did you catch, so, yeah, 4 times 3. Why did I cross those out? I don't know. Okay, so yeah, it should be 12 square root of 2. So that would give us, here, 12 square root of 2. Did I mess this one up? No. Okay. Cool. Thank you. Okay. So what I was saying is one of the problems on the homework, it gives you a square, it says the diagonal is 16, and then it wants to know the perimeter. So you would need to find the side length first, and then multiply that side length by 4. So to go from the hypotenuse to the side length, you would need to divide by square root of 2. So you do 16 over square root of 2. Get rid of that. Eight square root of 2. So the side length is 8 square root of 2, 8 square root of 2, 8 square root of 2, and so on. Multiply that by 4. 8 square root of 2 times 4 would be 32 square root of 2. And then actually the answer is in a decimal, so at this point you could plug that into a calculator. And every calculator is different. Let's see. 32 square root of 2 is 45.3. So this one would come out to 45.3, like that. Like, was there anything else I need to tell you? When you're doing the homework problems, make sure to identify which special right triangle it is at first. So the first thing you should be doing is figuring out whether it's this one or this one, and then solving accordingly. Okay, so you can get a laptop, get started on your homework.